Okay, question number 10. Consider the arithmetic sequence APQ where APQ is not 0. Show that the 2p minus q equal alpha. This series over here is as arithmetic sequence, and then it should satisfy the principle of arithmetic mean, which I mean if any sequence is arithmetic, the second term is arithmetic mean between fourth term and third term. What I'm saying is, let's say arithmetic sequence. Think of a first sequence. The first number is 2 and difference is 2. 2 is gonna be like 2. Adding 2 is 4, 6, 8, and goes to infinity like this. What I mean is, if you can think of any consecutive 3 terms, the second term is this is 6 is always arithmetic mean between fourth and third term. It goes like this. So 6 is between 4 plus 8 divided by 2 is 12 divided by 2 is 6. So this kind of rule always apply. What I'm saying is, let's say arithmetic mean is U1. In this arithmetic sequence, this equation, in the middle term, P is always A plus Q divided by 2. This is always true, which means that we can just adjust this one. You can put the A, so you can press A plus Q equal 2P. And moving Q and the other side, you can say A is 2P minus Q. So this is true in the arithmetic sequence. So this one, right? So consider geometric sequence this time, AST, where AST is not 0. Show that this one is true. The same thing applies for similar thing is applies for geometric sequence. Geometric sequence, any consecutive 3 terms should satisfy the principle of geometric mean. What it means is square root second term is always same as product of fourth term and the third term. So in this case, S squared is always A times T. So it's already over here. So let's say how do I explain this? Let's say this is arithmetic sequence. Let's say AN, its first term is A1, and then R to n minus 1 power. So let's think about any term like A5, 6, 7. So let's see, A5 will be, what is it? A5 will be A1 R 4 times, right? And A6 will be A1 R 5th power, and A7 should be A1 R 6th power. And if you think about it over here, the second term over here, this one, so this one square, so A1 R to the 5th power square is always same as the product of first and third term, which is A1 R to the 4th power times A1 R to the 6th power. Differentiating, simplifying left hand side will give us A1 square R to the 10th power, and simplifying right hand term will give us A1 square R to the 10th power. This is exactly the same. This kind of principle always works in geometric sequence. Delete this one. Okay, so this is proved. First term in both sequence is A, yeah? Both arithmetic sequence and geometric sequence first term is A. Okay, got it. It is given that Q and T equal 1. So which means the Q is 1 over here, T is 1 over here. So show that P is greater than 1/2. So this time they give us two sequence. See, let's say arithmetic sequence is given by APQ. APQ, so it's given by A, second term is P, third term is Q, but Q is 1, right? And then geometric sequence, three term will be A S T. A is A, S we don't know, T is given 1 over here, so 1. So show that P must be greater than 1/2. So in this equation, because this is arithmetic sequence, as I mentioned, these two principles must work. So first condition is this one should satisfied. This one also should be satisfied. So how should I say? So over this one, arithmetic mean should be applied. So P should be A plus 1 over 2, because this is arithmetic mean. This means geometric mean principle should apply. So S squared must be A times 1, which is A. See, A equals S squared. S is what? S is not 0. S is not 0. So some number not 0 squared is always greater than 0. Greater than 0. This is true, right? So S squared is greater than 0, meaning that A also greater than 0. This is true, meaning that get A from here. So we can express A as 2p minus 1, right? So A equal to p minus 1, and this A must be greater than 0, left hand side greater than 0, meaning right hand side also must be greater than 0. So this is greater than 0, which means that P must be greater than 1 over 2. So this is derived. Consider the case where A equal 9, S is greater than 0, and Qt equal 1. Write down first 4 terms of arithmetic sequence. So first term is given APQ. So arithmetic sequence APQ, A is given to 9 and Q is 1. So AP1. So arithmetic sequence is like AP1, but A is what? A is 9, right? A is given as 9P1. Write down first 4 terms, so you can easily deduct that in this case P must be 5, because this case, right? So P is arithmetic mean between 9 and 1 divided by 2 is 5, which means that P must be 5. So fourth term will be, so this is minus 4, difference is minus 4, another minus 4 will give us minus 3. So this 4 number, this is the answer. Arithmetic, this 4 number is first 4 terms of arithmetic sequence. Geometric sequence, let's see that. Geometric sequence initial value is given by A, which is 9, and second value we don't know S. The third value is T is 1. So this is geometric sequence, but it says S greater than 0. So because S is greater than 0, this case let's like this. Okay, so geometric mean principle, so S squared must be 9 times 1 is 9. So S can be plus minus 3. Because S is greater than 0, S must be plus 3. Right? So we can write S as a term of 3 over here. So S must be 3. And what is first term? So this is 1/3. This is 1/3. And that 1/3 will give us 1 over 3. So this will be the second answer. Next question. The arithmetic and geometric sequence are used to form a new arithmetic sequence UN. It says new arithmetic sequence. The first three term of UN, which is arithmetic sequence, is U1, U2, U3. U1 is 9 plus ln 9, U2 is 5 plus ln 5, 5 plus ln 3, U3 is 1 plus ln 1. As you see here, so new arithmetic sequence start with the first natural number. The first natural number part, not natural, it's integer part, start with 9, 5, 1, which is 9, 5, 1, negative 3, goes like that way. Second ln term, the number after ln start with 9, 3, 1, 9, 3, 1. So next number will be ln 1 over 3. You see the pattern now, right? So find the common difference of the new sequence in terms of ln 3. Because they said this is a new geometric sequence, this number must be a geometric sequence, right? So whatever geometric sequence is geometric mean. Oh, sorry, it says arithmetic sequence. So this three sequence must comply with arithmetic mean rule, which is U2. Second term must be arithmetic mean between first term and third term divided by 2. So which means U2 is which means that the 2 times U2 is U1 plus U3 is the same meaning. So 2 times U2, which what is it? 2 times 5 plus ln 3, so 10 plus 2 ln 3 is U1 is 9 plus ln 9 plus U3 is given 1 plus ln 1. ln 1 is actually 0. Okay, doesn't mean anything. Yeah, of course, this is true. It's going this way is 1, and then ln 9 is 3, ln 2 going that way is ln 1. Yeah, it should be same. So why I'm doing this? I don't need to do this. What I need to find is common difference, right? It says just find the common difference, which means the common difference is whatever U2 minus U1. U2 minus U1, or it should be same as U3 minus U2, whatever. This is defined as D in a arithmetic sequence. So what I can do is U2 is 5 plus ln 3 minus U1 is 9 plus ln 9. This is D actually, right? So if you calculate this one, it says 5 minus 9 is negative 4 ln 3 plus ln 3 minus ln 9 is ln 3 squared. So that square comes in front, so 2 ln 3, and then answer will be negative 4 minus ln 3. This is actually D, common difference. Show that this one becomes left-hand side becomes right-hand side. Okay, second question here. Left-hand side, what it means is looks like summation of the first 10 term of UN, which is new arithmetic sequence. So if you just write it down, the UN, because you already know that U1 and D, you can write down UN as a kind of general term. So UN is arithmetic sequence. The first term is 9 plus ln 9 plus ln 9 plus m minus 1, and common difference is where is it? Negative 4 negative ln 3, negative 4 negative ln 3. So let's simplify this equation a little bit. So it's 9 plus ln 9 plus negative 4 negative ln 3 times n minus 1 multiplied on that one will be plus 4 plus ln 3. So simplifying this, 9 and 4 together should make 13 over here. This one is 2 ln 3, this is ln 3, so it will give us plus 3 ln 3. Let's say is negative 4 plus ln 3 times n. So this is general term, right? So what we can do is enter this general term over here, and then over this general term. So sigma is I start from 1 to 10th term of general term is 13 plus 3 ln 3 minus 4 plus ln 3 parenthesis everything n times. So let's this bracket like this. We have to calculate this. So it becomes that as you see, this sigma notation is about I. Oh, so this should be write down as I over here, not n, right? So this must be I. So this sigma notation is about I changing from 1 to 10. So 13 3 ln 3 is nothing to do with I. So we can write down with 13 plus 3 ln 3 in the front, and sigma as I start from 1 to 10. What is left is just 1 over here because this one goes inside the same expression. And same thing applies as 4 ln 3. Same thing applies. It has nothing to do with I, so we can put it in front, which is 4 plus ln 3 parentheses, and what is left is a sigma notation. I start from 1 to 10, I is left over there. So we can calculate, so 13 plus 3 ln 3, and the sigma I from 1 to 10, 1 is what this one means over here, means 1 add plus 1 plus 1 plus all the time to 1. This is, there are 10, 1. So what it means is 13 plus 3 ln 3, and there are 10 1, so it's going to be 10 minus 4 times ln 3. Sigma I from 1 to 10 I means 1 plus 2 plus 3, yeah, like that. So this one means 1 plus 2 plus 3 plus all the way to 10, which is we can calculate by simple formula. So 10 over 2, first term is 1, last term is 10. We can calculate like this. So let's simplify this one more time. So it's going to be 130 plus 30 ln 3. This equation of this one here is just 55, you know? If we add from 1 to 10 is 55. So 55 times 4 will give us 220 minus 55 ln 3. So final answer, 130 minus 220 is minus 90. 30 plus minus 5, 55 ln 3. 30 minus 55 is minus 25 ln 3. So this is the answer. So this is the same result over here. So this is the answer.